Today I'll be giving Leetcode weekly contest 472. This contest happened on 19th of October, Sunday, and I wasn't able to appear in it, so I'll be giving this contest virtually. So yeah, I am going to start it now, and obviously I won't be discussing the solutions as I solve the problems. I will be writing down my solutions, but I won't be sharing them as I solve the problems because I want to do this like a real contest, so I'll be doing them fast, and after I'm done with all the problems I'll explain whatever I could do. So so I have my pages here. Okay, yeah, so I'll be starting it now, and yeah, okay, this should open the first problem. I'll open the rest of them. This one must be hard. It's 7 points. Okay, smallest missing multiple of k. Okay, so basically the smallest positive multiple of k that is missing from nums. All right, okay, well, nums is pretty small, so yeah. So one way to do this problem is to just we can create a set of all the elements in nums, and then we can just go we can just keep incrementing I, and then we'll just see that if s dot find k times I double equals s dot n, then we just return k times I, and this will obviously give us an answer, so we'll just return -1 if this does not exist. This is 10 and 5, which are fine, I think, so I'm going to submit it, and it works. So next problem is the longest balanced subarray 1. So we are given an integer array nums. A subarray is called balanced if the number of distinct even numbers in the subarray is equal to the number of distinct odd numbers. Okay, so we have to return the length of the longest balanced subarray. Okay, so basically the number of distinct odd numbers is equal to the number of distinct even numbers, and this is small. All right, so we only care about the number of distinct elements basically, and among those number of distinct elements the number of odd and even should be equal. All right, okay. Yeah, so what I'm gonna do is all right, okay, all right, so basically we can create two sets, one odd and one even, right? And on the even set we'll push out the elements that are even, and on the odd set we'll push out the elements that are odd, and if the size of both of those sets is similar, then the answer will be maximum of answer comma r minus l plus 1. So we can do this by 2 pointers, but the thing is that let's just say how do we move pointers, right? So yeah, so basically in order to move the pointers, let's just create 2 pointers at both of the sides of the array. All right, so the thing is yeah, so let's just say that we create 2 pointers on the left end and the right end, and the total number of those values will be like that, right? Okay, so we can create 2 maps, and then we can see, so for example here the number of even are 3 and the number of odd are 2, so basically we see that both of them are even, so it doesn't really matter. Yeah, we can do this. So basically what I'm going to do is, first of all, I'm going to create a map, and it goes through every element inside nums, and it increments the element, and I'm going to create 2 pointers at the end of the array. So n is basically the size of nums. So what I will do now is Well, our answer is always, well, I mean, if the size should not be 1. Okay. Yeah, I mean, if we have only one element, then it would never be, you know, so R should be greater than L, and then we'll just see that if um, then we'll just see that okay, so we need to create 2 maps actually. So first one, let's just say that it's odd, and then another map which is even. So we can just do odd plus plus if okay, so I can do this. What the hell? So I can do this if x modulo 2, then I can do this, otherwise I can do an even x plus plus. So yeah, we can do that, and we can just check that if odd odd dot size equals even dot size. So this will be the first pointer that we'll have with the similar values. So we can just actually we can return r minus l plus 1. Otherwise we'll just see that if odd dot size is greater than even dot size, and we'll also have an else here. So basically the number of odd elements are more, then where should we move? It might happen that both. Okay, so this is wrong. Doing it like this is not very right, I think. Well, we can take advantage of the fact that this array is 1500, so we can do an often squared, but I am thinking about solving both of them because this must be big, right? Yeah. There should be a way. So by the time I think I'll just solve this one, I'll also think this in the back of my head. I want to solve this instead of this, because if this is solved, then that will be solved regardless, and I want to have the most optimal, so I'll solve this in the end. You are given 2 strings as n target, both having length n, consisting of lowercase English letters. Okay. Return the lexicographically smallest permutation of s that is strictly greater than target. Okay. If no permutation of s is lexicographically strictly greater than target, then return an empty string. Alright, so we have to return the lexicographically smallest permutation of s that is strictly greater than target. So we just need to basically first of all we have to check that it is possible. So we'll just see that what is the length. Oh, it's also very small. Yeah, okay, so what we can do is, there are only 26 characters, so yeah, we can just check yeah, we can try forming it with the every letter that we can. Yeah, so it might happen with us that basically, let's just say that we have B, B, B and D, and then another string that we have permutation is this. So this can be greater than this if we do B, C, B, 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 or rather we can do B, B, C, B. We can do this, but that's the thing, we have to know where the element is. Alright, how can we do this? PBA, ABC. I'm just thinking the most optimal way this could be done. Well, okay, got it. Hmm. So first check that we can make is basically we can form a string t which is equals to s, and then we can basically sort. So this is the best t that we can get by sorting all the t's, and the thing is that if t is less than target, we return a empty string because it's never possible if the best string is not able to do that. And then what we can do is probably how can we do so we try to match the characters. So if there are similar ones, then we match them and we only make the change once. So let's just say that the character that would be changed, so basically we can do it in a brute force way because the size of the string is very small. Yeah, so we can do this for every single character that at this position there should be a change. So we can do that, and then basically try to figure out yeah. So basically we have to make that change there, and before that everything should be either less either greater than or equal to, but it should not be greater than because this is the place we are making a change, so everything prior to it should always be equal to it, right? So what I mean by what I'm saying is no, it won't make sense, but it will make sense when I explain it. So if I fix an index where the change will happen, so at that position the element should be always greater than that, right? So and the elements prior to it have to be equal to it, and after that we can just do whatever we want. All right, so what I'm trying to do is that if in this position we make a change, yeah, this is a good problem. So I'm forming a vector of 26 characters, and I'm going to increment the frequency of this vector. So I'll just do this, and then I'm going to do this for every single index in in S. So what I'm going to do is I'm going to go for every single index, and then obviously I'll have to check if basically you know so all the so I yeah so I should be able to have some frequency. So let's just say I'm making a change in I, so every single element before I should be equal. So what I am going to do is I'll create a temporary vector tmp. Let's just have it to be equal to f, and then what I am going to do is I'm going to go from j equals 0, j is less than I, and j plus plus, and then I'll just see that if a temporary of j yeah, and also I'm going to store an answer here. Also a boolean value is useful, so I'll just create a bool OK equals false, yeah, maybe equals to true, and we'll break it, and if OK is true, then we'll just do res equals to minimum of result comma the string that we have formed. So let's just call it cut, and then I'm going to have a string of result which is equals to t, and then we'll just choose the minimum value. So basically the thing is that the temporary of j has to be temporary of actually it's not j, it's temporary of s of j minus a, or rather I can just form a value. So int value equals s of j minus a, and if the temporary of value it's 0, then we will make OK equals false, and then we'll break. Otherwise we'll just decrement temporary of value by -1. So if after doing all this, basically we have to choose the first character that is greater than the current one. So int let's just call it Euler, and it is equals to s of I minus a, and then we'll just go for int j equals Euler plus 1, j is less than 26, and j plus plus. So we'll just see that if temporary of j is greater than 0, then yeah, basically what we do is we yeah, so there should be a value that is greater than j. So we'll mark this as, let's just call it char c equals this. Yeah, so we'll just mark c as the first character, so it would be basically char of j plus a, and then we'll just break. So we will see that if c is if c double equals hash, then we'll obviously continue. Otherwise we'll add current plus equals c, and then we'll just go throughout the entire 26 letters inside the temporary, and we'll just add if tmpj is greater than 0, then we'll add current plus equals string of how do I do this, temporary of j comma character of j plus a. So this way we can have our current, and yeah, also here we should also add curl plus equals s of j. So in the end we can just return our result. I think this might have some issues, so I'm just going to print out cur every time I do this. Let's see. Okay, I didn't yeah, I have to define current. There we go, should work. Okay, so why do I have more characters than I should? Alright, so ACBC, interesting. Okay, we should not have these many characters, but okay, whatever. So I go why do I have more characters than I should? Yeah, I mean, so basically I go from this, and then I see if the value is 0, then I do that, otherwise I do this. Oh, it should be on a target. This should be target. Yeah. This should be target again, and this should also be target. Yeah, so I think this should work now. Why do I have these many characters? Well, we try to match B, then we have C, then we have A. I don't know where this is coming from. Well, I'm adding C here, so we can just put out a current. I don't think this should be a problem for us. Okay, so this right here is BC. So we have BC, which is fine here. Oh, then also we have to decrement it.
right? So TMP of basically target of I minus, because yeah, it should be actually C minus A, because we are using it, right? Yeah, so it should be fine now. Oh, let me just check it once. So it's PCA EELT and then wow, okay. It should be greater, right? Strictly greater, okay. I think this should work now. Yep, it worked. This was actually a good problem. How many solves did it have? It had 2, 7, 8, 9 solves. It's a good problem. I like this problem. So I'll be doing this now. It only has 120 solves, but I don't want to do this because this can be easily done with O of n square. It's for just 1500. I want to do this one. This is a harder version of this problem in which we have to formulate an O of n log n solution, which I think I have some idea about because I was thinking about it also. So I'll just make some. What the hell? Alright, let's start writing. I'll be writing on my notebook page, but I'll also be making some comments about some things. I'll just be right back.